Okay, to learn the types of reactions, we were making a foldable in class. What we did is we took a white sheet of paper. It can be notebook paper if that's all you have. We folded it hot dog style, broke it into 6 individual pieces, cut little flaps for the foldable. Your notes don't have to look exactly like mine. Okay, so the first type of reaction we're going to look at is a synthesis reaction. Synthesis, synthetic, means to build or to make. So a synthesis reaction is defined as 2 substances which combine to produce one product. So let's write 2 reactants. Let's do our reactants in red. 2 reactants combine to produce one product. So we're going to recognize this as one product after the arrow. So we have our product here, and there's only one of them. So we have lithium plus chlorine yielding lithium chloride. And here are my reactants. So we have reactants and our products. I'm so sorry, this is a mess. The second type of reaction we learned is a decomposition reaction. Decomposition, to decompose, break down. So it's the opposite of a synthesis reaction. This is where we're going to have one substance or one reactant. Let's write the word reactant up there. So one reactant breaks down or decomposes into 2 or more products. We recognize this one as one reactant before the arrow. What I'm going to expect you to be able to do is look at a reaction like this and say, oh, that's a decomposition reaction because I have one reactant and 2 products. So here's my reactant and here are my products. If I'm going too fast, just pause the video and write your stuff down. The third type of reaction, single replacement. So the synthesis reaction is one we did the steel wool. I'm trying to think what the other lab we did with this, the demonstration synthesis reaction. The decomposition reaction is the one where we decompose hydrogen peroxide into water and oxygen using the potassium iodide as a catalyst. We also did the Screaming Gummy Bear in the back. Single replacement, this is where we have one element and one compound on both sides of the arrow. A more reactive element replaces a less reactive element. We're going to recognize this by having an element and a compound on both sides of the arrow. So this is the one where we threw sodium in water and produced sodium hydroxide and hydrogen gas. This is also the one where I added zinc plus hydrochloric acid and formed zinc chloride plus hydrogen gas. So we have potassium iodide, which is my compound. Bromine is my element, and it gave me a compound plus an element. We're going to use the activity series for single replacement on Tuesday of next week, so we'll look at that. Now, the fourth type of reaction, this is not going in the order we did in class, but we still need to know them all, is a double replacement reaction. This is the big guys. So a double replacement reaction, the positive cations in 2 ionic compounds switch places. We recognize this because we have 2 compounds on both sides of the arrow. So here we have iron chloride or iron 2 chloride plus sodium aluminate yields sodium chloride plus iron 2 aluminate. So you can see that the iron and the sodium are cations switched places. And we have a compound plus a compound yields a compound plus a compound. The next type of reaction is a combustion reaction. This is the one where I use the gas bubbles on my hand. This is also the Screaming Gummy Bear because once the sugar began decomposing, the oxygen caught fire and combusted. So this is information's on the back of our notes 1 as well. So this is a hydrocarbon, burns in the presence of oxygen to produce carbon dioxide and water. The way we're going to recognize that is we'll have a hydrocarbon plus oxygen yields carbon dioxide and water. Okay, so here's our example. We have our hydrocarbon plus oxygen yields carbon dioxide and water. And then last but not least is our neutralization reaction. This is what you saw when we made the sodium hydroxide with the single replacement reaction of the sodium and water, and then I poured the vinegar on it. That was a neutralization reaction. This is a reaction between an acid and a base. You're going to recognize this because acid starts with a hydrogen and bases end with a hydroxide. So we're going to have a hydrogen and a hydroxide as reactants. So let's go. This will be, these are our reactants. So I need to do that in red. These are our reactants. Alright, so for instance in this case, potassium hydroxide plus phosphoric acid yields potassium phosphate plus water. Alright, so those are our 6 types of reactions. You are going to be expected to be able to identify them. So let's look at the back of our homework notes number 2, and let's look at that. Let's look at that. So a hydrogen plus an oxygen yields a water. So we're synthesizing. So this would be a synthesis reaction. So this is a synthesis. That pen doesn't write. So this would be a synthesis reaction. Element plus an element giving me a compound with one product. So again, a synthesis reaction. One reactant yields 2 products. That would be a decomposition reaction, because this is the way we're supposed to identify it, as one reactant. These guys give one product. Okay? An element plus a compound giving me a compound plus an element is a single replacement reaction. Again, element, compound, compound, element, single replacement. Let's go down to this one. We have one product, so a synthesis. Again, one product. This will be a synthesis. A hydrocarbon plus an oxygen giving me carbon dioxide and water will be a decomposition. I'm so sorry, a combustion reaction. Hydroperoxide decomposing into water and oxygen will be a decomposition reaction. And hydrocarbon plus oxygen giving me carbon dioxide and water will be a combustion reaction. So down here we have a compound plus a compound yielding a compound plus a compound. So this will be a double replacement reaction. And we'll practice this on Friday and on Monday, and then we'll start our activity series.